All right, welcome back again. This is Physics 30, and we're going to do, this is the second video for the vector addition using math and calculated instead of using the graphs, instead of doing it graphically. I know that's still math, but anyway, that's a calculation addition. So we're going to now do these two like I was going to do before. I just realized that I shouldn't have deleted all the things. I'm just going to write it really quick here. We should make again, this should be really neatly done, and north, south, west, east should be actually straighter, not curved like that. You get the idea. So we have the coordinate system, just so we're all clear, and then also a little drawing here. Now these angles are slightly different than we want to do these actual ones here. So 25 degrees east, north of east. Now I'm just guessing that it's something like this, and then east of north 15, so it's something like this and this, something like that. And then the resulting vector, I'll do blue for now. It's going to be like this, something like that. Okay, so where this is d1, d2, and this is the resulting vector here. I'll just put r. It's a little bit of a lazy r there. Okay. And then the question will be like, okay, what's this angle here? Okay, so this we're going to call theta. And actually this, I know r is used a lot, the resulting vector. In this one, I just want to call it, let me call it d total. D with a subscript, a capital T. And that'll just be the total distance. Sorry, displacement. We're talking about displacement, not distance. All right. So, yeah, and I actually call it total displacement up here. So let's go ahead and add these together. Now you'll notice something here. This is not a right angle triangle, so we cannot use this. We cannot use this. Those are just for right angle triangles. We still can use this as the cosine law, and we can still use the sine law. So let's first take a look at the cosine law, and you'll notice that actually this section, this part of it here, this initial part, is exactly the same as the Pythagorean's theorem. So this is just a special case of this equation. And so what we add on here, well, in this case subtract, is 2ab cos of c. And here, if the cos of c in this case would be the opposite angle here. If it's 90, then cos of 90 degrees is 0. So all this whole term becomes, this whole thing becomes 0. Okay, if c is equal to 90 degrees. Okay, now in this question, it's not 90 degrees, so let me just erase all that, because it's not 90 degrees, it's some other kind of angle. Looks like, I don't know, maybe 110 or something like that degrees. So we need to just use this whole equation here. Okay, now in this equation, it's actually a little more powerful in that c doesn't have to be the long one, but in this case we're going to keep it. I'm just going to draw this triangle here again. Oh my goodness. Okay, let me try to draw it again here. So this is one angle, then it goes up like this, and then we have this third line here. So if this is C, then this is angle C. If this is A, then this is angle A, and it's capital. And then this one would be B. Sorry, if this is B. Okay, so the angle that's directly across from the line, so B, the line is here, so the angle across from it is the B angle. Okay, and same with A, it's supposed to be capital A, if you can see there. And C, this is capital C. I know it's smaller than this one, but it's just the size. Maybe I can try to make it look a little better. So this is C, nice small c, and then this one is going to be a giant C, capital C. Look at how much bigger it is. Okay, so we can just use the equation as it is. Again, you'll notice lowercase c's, these are all the length of the lines, and then this is a giant C. It's for the giant letters, the capital letters, are for the angles. So I guess the question is, do we know all the angles, and can we figure them out? So I hope we can, but we'll see if we can. So we know C, or no, we're trying to find C. So we're going to put C squared equals, C squared is equal to A squared plus B squared minus, and we know A and B, minus 2AB, so we know everything so far, cos of C. Now C is not given, it's not this one and it's not this one. Okay, we need to still figure out what that angle is. And so the question is, can we do that? Can we figure that out before we without drawing it all out and doing it graphically? And so that's where you kind of need to know your rules about triangles and different things. So let's see if we can. I'm going to get another color here. And I'm going to try red. So if this is this east, then this angle here is 25 degrees. Okay. And then this angle here from straight north, so this is straight north, this angle here is 10 degrees. Okay, so if this is straight north, what would be the angle here? Now if we extend this, let me grab another color. I appreciate this is really small, and I'm thinking that it's going to be maybe too small to be useful for you guys, because you might not be able to see this at the very... Okay, so it's going to be hard to show you with this, but hopefully you can figure out. If we put another line above here that's parallel with the east-west line. This is two parallel lines with a line intersecting it, and so the rule is whatever this angle is the same. So actually this angle here is also 25 degrees. And then the question is, from this line to this B line, how many degrees is that? Well, this to the upright one is 90 degrees. So from here to here is 90 degrees. So it's 90 plus 10 plus 25. So maybe this is just a side calculation, but C is equal to 25 plus 90 plus 10. And that should be 125 degrees. Okay, so I'm sorry this is a huge mess. Draw it out yourself and see if you can figure out that, but essentially I figured out this is 25 degrees. I did a parallel line and I figured the inside of this was 25 and then 90 and then 10, so hopefully you can follow that. Okay, now let's continue our calculations, and I'll switch back to the blue pen. So C is equal to the square root of all this fun stuff, a squared plus b squared minus 2ab cos of C. And what we're going to do is now just put in all the values. I'm going to put the square root symbol later on because there's going to be a lot of things written inside of here. So a is this value here. This is, I guess you could say a. This is going to be b. So a is 35 kilometers all squared plus 15 kilometers squared minus 2 times 35 kilometers times 15. Okay, and then times the cosine of 90, sorry, not 90 degrees, otherwise we won't be doing this, cosine of 125 degrees. Okay, so it's all multiplied together before it's subtracted. And it's the square root. Don't forget the square root. If you don't take the square root at the end of it all, you'll get it wrong. So let me again get out my calculator. This is a much bigger one. There's lots more opportunity to mess this up, but let's see what we can do here. So I'm going to try to do it all in one shot. The square root. Actually, that's a lie. I'm going to do it in sections. Cosine. I'm starting with a cosine of 125. That's a negative number. Multiplying it by 2. By 35 by 15. Okay. Okay, so I get something like this. Again, I'm just putting this in steps, smaller steps. I haven't done the square terms here. But it ends up being something like this, 0.255 and some more digits there. Okay, and then we're going to add 15 squared plus 35 squared. So you should be getting something like the square root of 2052.2 and so on. And I'm going to take the square root of this. And I get 45.301 and some more digits. This we should only have as many digits as we have in the questions, and that's 2, so it's 45 kilometers. Okay, so hopefully when you drew this, you also got very close to 45. When you're drawing it graphically, if you got 44 or 46 or something close to 45, that's good enough. It's based on human error and all that. But hopefully this gives you a sense now. It gets a little more complicated when the two vectors are not at 90-degree angle. You have to start using these equations here and here. Now, we don't have the angle yet. This is the equation I'd use for the angle. Let's see if I can do that real quick. Right to the side. I'll do it in orange. So we want some reference angle here. And so I'm going to suggest that actually this angle B is good enough. Because that's with respect to A. We could go with respect to east and north and all that, but we just have to add 25 degrees and then we'd have it with respect to the east. So as long as I have it with respect, like in my diagram, it should be fine. So I'm actually going to look for B. That's the angle. So I'm going to say sine of B, capital B, that's the angle, divided by B is equal to, and I'm going to use the, I don't know angle A, but I do know C now. I figured out C here, and I know line C now, so I can go sine C over C. And now to get just B by itself, I go sine B is equal to, multiply both sides by B, so it's B sine C over C. And then we go B is equal to the sine inverse of B sine C divided by C. And then we put the numbers in there. And I'm just, this is crazy here, but I'm going to take this 45. So I'm going to say, I'm going to take this one and say C is equal to, this is lowercase c, not uppercase, lowercase c is 45 kilometers. And I'm just going to erase this just so that I got room to finish this other question out. Okay, so B is equal to sine inverse of B, which is the line here, which is the second one, so it's 15 kilometers. Sine of C, C is 125 degrees. All divided by, and this is multiplied here. and then all divided by c, which we figured out to be 45. Now really I should be using the unrounded version of 45.30308 so on kilometers. I shouldn't round it off for another calculation, but just it's gonna be okay if you did round it off. It's not gonna be the end of the world this time. Okay, so I'm gonna do all the math. Okay, so we're gonna take 125, take the sine of that, multiply it by 15, and I'm going to divide it by 43. 45, sorry. 45.308. Okay, and then I take the sine inverse of that. And that gives me 15. Whoa, sorry, lost focus there. That gives me 15.735 degrees, which is close to 15, I guess 16 degrees. Okay. And so it'd be 25 plus 16 would be how far from the east. But so you'd say the resultant dt. So I'm going to say another. I'll pick another color here. Let's go. Let's go purple. So dt. Displacement total is 45 kilometers. And then if we're going to go north of east, then it's 16 plus 25, which is 41, at 41 degrees north of east. And that's how you do it. Okay, so I have one more video on this coming out. I'll probably I'll do it for tomorrow. And that's for if you have more than 2 vectors. If you have 3 or more, then there's another method that's actually quite powerful, and it's so powerful it can also handle 2 vectors, but it takes a lot more explaining. So I hope I can explain it well, and I'll try to do it larger with not all this garbage in here. So see ya in the next video.